Welcome to the DIY Honda Garage channel. The DTC B1075 indicates a malfunction in the headlight switch backup circuit of the Honda Odyssey model years 2011 to 2017. This error code suggests that there might be an issue whereby the headlight switch is not functioning as expected, potentially due to a problem in the circuit that supports its operation. The components affected primarily include the headlight switch itself and the relay control module located under the dashboard of the driver's side. Understanding the roles of these components is crucial. The headlight switch allows the driver to control the vehicle's headlights, while the relay control module serves to manage the electrical flow to various lighting systems. In this case, diagnosing B1075 revolves around checking the connectivity and functionality of these components. It is essential to follow a structured diagnostic approach to ensure that all aspects of the headlight system are scrutinized. DTC B1075 reflects a malfunction in the headlight switch backup circuit, meaning there could be issues with how the headlight systems engage. The headlight switch is critical as it controls when the headlights are turned on or off, thereby ensuring visibility during driving. This switch is usually located on the steering column or dashboard area and is easily accessible for usage. The relay control module is situated inside the driver's under-dash area and is essential for regulating the current that powers the headlight system. This module receives signals from the headlight switch and initiates the relay to engage the headlights accordingly. A clear understanding of these components ensures that one can identify where the malfunction may arise during troubleshooting. One potential cause of DTC B1075 is a faulty headlight switch itself, which may not correctly complete the circuit needed for the headlights to function. Such faults may stem from wear, damage, or internal failures within the switch. Another possibility is that the relay control module is malfunctioning, preventing it from sending the right commands to engage the headlights. This module is vital for proper electrical function and responds to the signals from the headlight switch. Additionally, the error could be the result of poor connections or wiring issues between the relay control module and the under-dash fuse relay box. Adequate diagnosis involves checking each of these areas to pinpoint the exact failing component. The primary symptom associated with DTC B1075 is that the headlights may fail to engage when the headlight switch is turned on. This lack of response can lead to visibility issues, especially during nighttime driving. Drivers may also notice warning lights on the dashboard indicating an electrical problem, which is often linked to other circuit malfunctions. In some cases, the headlights may operate intermittently, functioning normally at times and failing at others, indicating a potential loose connection or failing component. Recognizing these symptoms early can help in resolving the issue before it escalates to more significant electrical failures. The first step in troubleshooting DTC B1075 involves clearing the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This process is essential as it establishes a clean slate for further diagnostics, allowing any present issues to be accurately recorded according to the current state of the vehicle's systems. Using HDS ensures that you are employing the proper tools designed for Honda vehicles, which can provide vital data and functions necessary for effective troubleshooting. After clearing the codes, you should prepare for the next steps, as this lays the groundwork for identifying if the issue persists or if the system's behavior changes. This step emphasizes the importance of proper equipment in accurately diagnosing Honda-specific issues. Following the clearing of DTCs, the next step requires turning the ignition switch to the lock position and then back to the on position. This action effectively resets the vehicle's electronic systems and prepares them for a thorough check. By turning the ignition to on, you're enabling the vehicle's electrical system, allowing for various tests. It's crucial to follow this sequence accurately to ensure that all electronic systems, including the headlight circuit, are primed for testing. This step does not directly diagnose the problem, but sets the stage by making sure the vehicle is in the right state for further diagnostics. After setting the ignition, the next troubleshooting step involves turning the headlight switch from the off position to the on position. This action is crucial as it allows the headlight system to engage and enables the diagnostic system to recognize its state. Waiting for at least 6 seconds provides the necessary time for the electronics to register the switch's action properly. Following this short waiting period, the next step is to check for any DTCs using the HDS. This step is particularly important as it determines if DTC B1075 is still present, indicating whether the headlight switch circuit malfunction has been resolved or persists. In this step, the diagnostic systems should be used to check for any current DTCs with the HDS. The outcome of this check is crucial, as it will determine the next troubleshooting actions. If DTC B1075 is indicated, this means the malfunction remains and that further examination is warranted. If the code does not appear, it suggests an intermittent failure, indicating that the system may be functioning correctly at that moment. In such cases, it is recommended to inspect for any loose or poor connections between the relay control module, connector, and the driver's under-dash fuse/relay box. The tracking of intermittent failures often leads to discovering underlying issues that may not surface during regular diagnostics. Once DTC presence is confirmed, the next step involves turning the headlight switch off to prepare for a detailed check of the lighting system. The HDS should be used to select the lighting mode menu, which provides the necessary tools to delve deeper into the lighting circuit diagnostics. Entering the data list allows engineers to examine specific parameters associated with the headlight switch, including its on-off status. This step is vital for determining if the headlight switch is delivering accurate signals as expected. Accurate data from this section helps in verifying whether the faults lie within the switch itself or other connected components. At this stage, it's necessary to check the on-off information of the headlight switch backup from the data list. This operational status will indicate whether the headlight switch is functioning correctly within the dashboard. If the information indicator shows off, this indicates that the system is not recognizing the switch's on position, suggesting a deeper issue, either with the switch or the connections. Should the indicator show on, it suggests the switch is operational, leading to step 9. If the indicator is off, further investigation into connections and potential failures is necessary, ensuring every element in the circuit is functioning as intended. In this step, after confirming the headlight switch's functionality, you will turn the headlight switch on. Subsequently, you will check the on-off information of the headlight backup using the HDS. This check is pivotal as it determines whether the system recognizes the headlight's operational status. If the information indicator reads on, this indicates that the relay control module is communicating effectively, and one should now proceed to replace the relay control module. However, if the indicator is off, the focus should shift to the next step for further analysis, indicating that the relay control module may not be providing the necessary connectivity to engage the headlights properly. Following the verification of the headlight being on, the next step is pivotal for confirming the status of the relay control module. If the headlight backup information from the data list indicates on, It implies that the relay control module can activate the headlights as expected. At this point, it would require replacing the relay control module to resolve the failure. If the information is not on, one should progress to connecting relay control module connector B, terminal number 14, to body ground with a jumper wire. This connection helps to bypass potential faults in the relay control module for further testing to ensure the integrity of the headlight system. In this crucial step, the diagnosis leads to connecting a jumper wire from relay control module connector B terminal number 14 to body ground. This connection serves the purpose of creating a direct path for electrical current to confirm if the fault lies within the relay control module. You will then check the status of the headlight switch, backup information once more. If the information indicates on, it signifies that the headlight system acknowledges the connection and the module should therefore be replaced. However, if the status remains off, it suggests replacing the relay control module as a necessary corrective action, indicating that the system cannot complete the circuit. Once the relay control module has been replaced, it is essential to perform a final repair verification. Start by rechecking all wiring and connections surrounding the headlight control circuit to ensure everything is properly secured and functional. Confirm that the new relay control module is installed correctly and aligned with specifications. It is also imperative to test the headlight functionality extensively under varying conditions to ensure that they operate correctly with the new component. This verification step guarantees that the repairs were successful, while also ensuring that other potential issues do not arise after the replacement. To mitigate future occurrences of DTC B1075 and ensure the vehicle operates smoothly, engaging in preventive maintenance is crucial. Regular inspections of the vehicle's electrical systems will help identify any emerging issues before they develop into serious problems. This includes checking all connectors related to the headlight circuit to ensure they are clean, secure, and free from corrosion or damage. Keeping track of any irregularities or warning lights on the dashboard can also assist in catching potential issues as they arise. Lastly, a timely visit to a Honda technician whenever unusual behavior is noted can provide reassurance and ensure that the headlight functionality remains reliable throughout the vehicle's life cycle. In summary, DTC B1075 pertains to a malfunction in the headlight switch backup circuit, which can impair the functionality of your Honda Odyssey's headlights. Understanding the role of components, such as the headlight switch and relay control module, is crucial in effectively diagnosing and rectifying this issue. The structured troubleshooting steps highlight the importance of utilizing the HDS diagnostic tool, checking current DTC statuses, and understanding the relay control function for successful resolution. Furthermore, emphasizing preventive maintenance plays a significant role in preventing future issues, ensuring long-term reliability of the vehicle's lighting systems. Maintaining awareness of these components and the importance of diagnostics and maintenance can ensure a safer driving experience. Please like and subscribe to the channel. See you next time.